This is lesson 5, and it's going to talk about quadratics and radicals. And it's a huge non-calculator lesson, okay? So, non-calculator lesson meaning there's many different ways that we're going to be exposed to quadratics. And knowing how to extract information quickly from that without a calculator is our focus. Okay. So it says quadratics review. We've already covered the different forms of linear equations like standard, slope-intercept, and point-slope. Now it's time to ask the question, what are the three most common forms of quadratics? Okay, so you have the standard form, and this is just recap the one that we talked about before where we set it equal to 0, and that it was a must set equal to 0 if you were given the ax squared and the bx term, okay? You have the vertex form, and then finally you have the intercept form. Okay. As far as what information we're going to be getting from this, it does depend on what's given to us first, of course. So let's look at the first one. Okay. Standard form. What can you tell me from looking at an equation that looks like this, characteristics about that quadratic? By hand without a calculator. Go for it.
Y-intercept is -6.
Yep. Y-intercept, you can say is 0, -6, or y is equal to -6. What else can you tell me about it?
Not necessarily a slope, but I mean it's got an a value of -2. I forgot why that's important, but it opens down.
So it opens downward. Okay, and I think what you were saying as far as it being 2, it's almost like a vertical stretch, if you will. Okay, so vertical stretch means it makes it skinnier. So a skinnier slope to it. Alright, so skinnier or skinny slope. It's not as like wide like this. That 2 would make it stretch vertically, which makes it a little bit skinnier. Anything else? Okay, so let me ask you something, because this is heavily tested what I'm about to show you. They will give you an equation in standard form, and then they want you to find the vertex like that. What would you do in this form to find the vertex? And I mean like the xy coordinate of the vertex. What would y'all do? I'm curious to know what y'all would do. There's an equation, almost everyone forgets it. Some people would say let's factor it. Because if we know the roots, otherwise the x-intercepts, then we can find the halfway point, and that's the x value. Okay? But that is over here.
Can't you do -b over 2a to find the axis of symmetry?
Nice. Very few people remember that equation, okay? So to find the vertex, in standard form only, you're going to get the x value would be -b over 2a. Well done. And then the y value is just plug that in to the function for your input, or your x value, and see what you get. Okay? So in this case, it would be a -b over 2a. So anyone, what's the x value of that? 5/4. So 5/4 is the x value of the vertex in this standard form. Okay? Okay. Now, remember I told you before, if you wanted to know the y value of something, it was called synthetic substitution. Those of you who are already taking pre-cal, you know that you just have to, and I showed it in previous videos, show the coefficients of your quadratic that you have, and then we're going to plug in 5/4 right here. So copy, multiply. And we should be already better with fractions and multiplication. So what's 5/4, guys, times a -2? -5/2. Because that 5/4 will multiply with 2, otherwise 2 over 1, and this does reduce to 5/2. And it's a negative. So now I have 5 minus 5/2, because we're adding those together. Well, this red 5, if you will, common denominator, would be 10 over 2 minus 5 over 2. And I'm only showing it because of the video, but you should be able to do this in your head. So the 10 minus 5 will give me another 5 halves. Do you agree? Okay. Now you're going to multiply 5 fourths and 5 halves, which would give us what anyway? 25 over 8. So now if you added those, otherwise let's go ahead and put 25 over 8, and then it's going to be basically adding this negative or subtracting what over 8? Negative 48. So 25, 3 more to get to 28, 20 more to get to 48 would give us a negative 23 over 8. And that would go here. Okay? So synthetic substitution, I know I used it for an easier example before. It's primarily more so for the fractions. To me, I think that's a lot easier without a calculator than trying to plug them in and then distribute the, you know what I mean, the powers and stuff. Because you're working with big numbers if you do that. Synthetic substitution, you can keep them small for the most part. I hope you acquire that, okay? Any questions? Okay, so let's go to vertex form. It opens what? This one right here.
This one downward.
Opens downward because that is a negative 0.5. Is it a narrower shape or wider shape or the same?
Wider.
It's wider. So it's like a vertical compression is basically going to just make this, whoops, that's not a parabola. A vertical compression, think of just vertically compressing it, it would make it wider. So we're going to say wider shape. And then what is the vertex? Negative 3, negative 8. This one's easy because it's already given to us in that form. Now I know I jokingly kind of gave you guys transformation rundown of anything with the x, otherwise ex-girlfriend, ex-wife, so on and so forth. You do the opposite. And anything outside with the y, happy wife, happy life, you follow the rules, it would be a negative 8. And I hope that sticks with you because then it's easy to remember those transformations. Now, let me show you something. With all that, and when students get that under their belt, you get to either pre-cal, or sometimes in Algebra 2 when you do conic sections, they have these equations on a formula chart, and this vertex form would actually look like this. And I wish they wouldn't do that. But textbooks and notes are different. Okay? Because if you use my analogy in this form right now, it wouldn't work. The y has to be alone for you to do the follow the rules with the y value. Otherwise, you're to interpret that as being in parentheses. Simple errors that I just want you to be aware of, okay? Without having to do 20, 30 problems. Questions? Okay, so intercept form. Intercept form is definitely very visual, and it concentrates on those zeros or those roots of the function. Okay, so let's go ahead and graph what we were given. This is going to be graphed as a what? A negative 4. Good. So there's your x-intercept. The other one? 11. And just for extra practice, what did this 5 halves tell us? It's upward, and is it wide or narrow?
Yeah, narrower.
Think about it. 5 halves is bigger than 1, isn't it? So if you multiply your height by 1, nothing changes. But if you multiply it by something bigger than 1, it's going to be a stretch of some kind. Do you understand? So a stretch, and I don't know if I said this incorrectly just now, a stretch would make it what? Narrower. Okay? So this will be a narrower, narrow shape. It does open up, and our x-intercepts are negative 4, 0, and positive 11, 0. And just for extra information, if I wanted to find where this vertex was, what do I do? Find the midpoint between these two intercepts. Will that work with a cubic A quartet, no, absolutely not, because it's weird, and there's a lot of factors going into all that stuff. This is only for strictly quadratics, x squareds, okay? Let's go ahead and find that midpoint. We talked about this. Sometimes we made this a little bit difficult. How do you find the midpoint between negative 4 and 11? Add them, divide by 2. So negative 4 plus 11 is 7 divided by 2, 3.5. So at 3.5 is where that x value is, right? Otherwise 7/2. And then you could just plug that in right here for your input x. So let me highlight it in green. You would plug any one of those in here, and then whatever you get for this whole thing, that's your y value. For the sake of time, we won't do that right now. Okay? Questions? Okay. Graph the function, which is already graphed. Here's your quadratic standard. We have values such as negative 3, negative 2, negative 1, 0, 1, 2, and 3, which give you what? 9, 4, 1, 0, 1, 4, 9. What kind of function is this? Is this even or odd? In case you have this question, is this an even or an odd function?
Even.
Why is it even? Okay, so both of you said a little bit the same. It's a parabola and because of the 2. So a lot of people think that it's an even function because of that. But that's not why it's even, okay? And some people think that an odd function, and I had this misconception too, that this would be an odd function because of that. Okay? What I want you to do, first of all, x cubed looks like this. Okay? Even and odd functions look like this. And they will test this possibly on the PSAT, for sure on the ACT. Even functions, they reflect across the y-axis. And the words are this, watch. Opposite inputs, let's say 3 and negative 3. Opposite inputs yield the same output. You with me? And in weird function notation, it looks like this. Where opposite inputs are going to yield the same output. It could be positive, it could be negative, but the outside is the same. Let's look at odd functions. Okay? What do you, in words, the way I did the drawing, what would you say?
Opposite do not yield the same output.
Okay, so close.
Opposite inputs
Equal
opposite results.
opposite outputs.
Opposite.
Okay? And I know what you were saying, but you have to show that they are in fact opposite to one another, okay? Opposite inputs yield opposite outputs. In other words, if I went 2, I would get 8. But if I went a negative 2, I would get a negative 8. You with me, guys? So opposite, hopefully solidifying the fact of negatives are opposites. Not reciprocals, but negatives. Because they add to form 0 cancellations. A cancellation of 0. Now, this one looks weird because it looks like this. So pretend like this is the original, and this is opposite input yields the same output. So that this would look like opposite inputs yield opposite outputs. You with me? Okay. All right. So what about the maxes and mins, guys? What do you see here? There's no maximum. And the min. If I ask you, what is the min? What would you say? 0. Just by itself, 0. So let me ask you that one more time. What is the min? It's this 0. This is huge, especially in calculus. Okay? Where is the min? It's this 0. Okay? I know it's subtle, but it's hugely important. Okay? Because sometimes, actually, let me take this equation and I'm going to change it by doing a vertical shift 2 units up. On this equation, what is the minimum? 2. Where is the minimum? 0. 0, right? X equals 0 is where the minimum's at. Y is equal to 2 is what the minimum is. Okay? Alright. Question for you now. We know the vertex is 0, 0. We know that it opens up. It's the normal shape, so it's not narrow nor wider. And one more thing. What's the axis of symmetry, and how would you write it in correct notation? Go ahead.
X equals 0.
X equals 0. Because x equals, in this context, is a vertical line. Okay? Alright. Let's see. There was maybe one. Oh, that was a question. I shifted this 2 units up. My question to you is it still even? Yes, why? Because you can still reflect it across the y-axis, right? If you shifted this graph 2 units up, and it looked like this, and still the properties of even, opposite inputs yield the same output, would still work. See, this is odd. Opposite inputs yield opposite output. What if this is my last question on this slide. What if I took this graph and I shifted this graph up 2 units, where it's x cubed plus 2? Is it still odd? No. It's not still odd. Because over here on the original one, it does have a symmetry about the origin. Now, this is the last thing. Opposite inputs means it's reflected across the y-axis. So this right here that I just highlighted would come here. And then opposite outputs means that it would reflect across the x-axis, where this would ultimately lay on top of that, through 2 folds, if you will, 2 reflections. Would the same thing happen if I shifted this up? It wouldn't. Because if I folded across the y, it would go here. And if I folded across the x, it would go way down here. But that's not where it was supposed to go. It was supposed to go here. So the moral of the story is, odd functions need to have a symmetry about the origin. And they have to satisfy the opposite inputs, yield the opposite outputs. How many of you play chess? Okay. So even if you don't play chess, what I want you to know is also with odd functions is that they rotate. Okay? So look at my original x cubed, not the x cubed plus 2, but the x cubed. Okay? So let me highlight it in orange right here. They rotate 180 degrees. So for instance, to me, the reason why I asked for chess, to me that kind of looks like the path that a knight would move, 1 and then 2 up. And a rotation 90 degrees clock or counterclockwise would create something that would look like this. And if I rotate it 90 more degrees, it would create this. So a rotation of 180 is the last thing. I know I might have overkilled that, guys, but those are other things that I feel that a lot of people don't know fully, okay? And notation-wise. Alright, be ready for SAT questions like the following. In which of the following functions, because we have 3, just mark this off in your notes, guys, that copied off too much G's. So I have f of x, I have g of x, and I have h of x. And which one of these functions are the zeros expressed as constants? H. So h of x. And what are the coordinates of those zeros?
0, 8, 0,
Try again.
or
8, 0, right? And
negative 2, 0.
negative 2, 0. Common mistake, no worries. Alright, so zeros at 8, 0 and negative 2, 0. In which of the functions above is the y-intercept represented as a constant? F of x. Yeah, the first one. Because y-intercepts occur when x's can cancel out to 0. And if I put 0 in for x, right here and here, these go to 0, so you're just left with 12. And what are the coordinates? Anyone? 0, 12. You good? Okay. And then number 3, in which of the functions above are the coordinates of the vertex represented as constants? G of x. And what are the coordinates of the vertex?
-5, -6.
Perfect. Find the y-intercept of G. What would I do to find the y-intercept of G? Plug in 0 for x, right? So here's 0. Plus 5 is 5. Squared is 25. Don't forget your PEMDAS. So exponents first. Then multiply to get a -50. So it would be what? So we'll write it as 0, -56. Okay? Any questions? Okay, so that one was pretty straightforward. Let's get some more practice. This time we're going to do the exponent rules with negatives and also things involving radicals, okay, on the other slides. All right, so let's go ahead and simplify each expression. All right, so 5 and 20 will go to 1/4. 1 is understood up top. The B moves. The C moves. So I would do this, and some people are struggling and forgetting to do this on quizzes. I would just do, just like I'm showing you, change them and blot it out so that you can quickly kind of simplify afterwards, okay? Does anything else simplify? We moved, but we didn't simplify anything else, did we? So we're left with a to the 4th, c to the 6th, and b to the 3rd. Done. Okay? Next one over here. What is the answer to this? 11. Because it's just the square root, right? And again, I'm only overkilling this for people who aren't physically here. So we'll take the square root of 121 and we'd get 11. Okay? What should we do here? Not what should we do. What would you do there?
First square root of 16 to the power of 1/2 or square root.
Okay, so the first thing he's choosing to do is work with this. And I think I heard 2 different ways to work with this just now. Okay, let me see. One, I think someone mentioned, let's apply that. It's not really a form of distribution, but you know what I'm saying. We're going to apply that to all the powers. So it'd be 16 to the -1/2. It would be this to the -1/2. And then finally it would be this to the -1/2. Guys, can you tell me, we've talked about this week, why can't I do that right now? What have I mentioned this week that says you can go ahead and quote-unquote distribute or apply this to all the pieces? Because it's multiplication and it's all one term. All of this is just one term, glued together through multiplication. Okay? So now this is understood all over 1, right? Do you agree? So we will now multiply these powers, and this will become, first of all,
It's 16 power of 1 power.
yep. So there is an understood 1 there that multiplies with this -1/2. I just didn't need to write that, but you're absolutely right. Guys, whenever I multiply all of these powers, would you agree that this one will be negative and this one will be negative after I multiply? Yeah, so those are also going to need to move. Okay? So this 16 will move downstairs as the following. The x to, let's multiply -2/3 and 1/2. What do we get? -1/2. What do we get? What do we get for this term after we've multiplied the powers? X to the
7 over 6.
1/3?
1/3.
Because you're multiplying?
No.
Power raised to a power you multiply. So -2/3 times -1/2 will become a positive 1/3, right?
Yeah.
And then this y is going to end up moving downstairs as what? Y to the power of... So first of all, maybe I should have done this instead. So 2 times... Yeah. 2 times negative 1 would be, or negative 1/2, this right here would become y to the negative 1. But then it would have to move downstairs. So it would become y to the positive 1. If you need to rewind that video just a little bit right there, that's fine. Please do so. But notice that we just skipped one step. Okay? Would you agree with the running answer right now? We haven't fully simplified it, but would you agree that it's correct? Yeah. Okay. So fully simplified, what would you do? Okay, yeah, 16 to the 1/2 is a 4. The y stays on the bottom, right? Do we need the 1? Y to the 1 power? Nah, it's understood. And then the cubed root of x. My question to you is, could you write it like this? Yeah, you can. And that's totally acceptable. So this, or you might see it like this, would be the answer fully simplified. Okay? Let's move on to number 8. All right. One term glued together with multiplication. Can you tell me what we talked about this week? The understood number that lies right there. Not a 1, but a 2, because this is square root. And the reason why I bring that attention to that is because these pieces inside, 1, 2, 3, 4, 5, 6, 7. I'm only doing this for the first one. What would you break up 48 as? What could we break up 48? 16 and 3. Okay, remember we're thinking about 4, 9, 16, 25, so on and so forth, okay? So, and yes, this 16 is 4 times 4. So this would come out as a 4. The 3 stays in. And the reason why I brought attention to this understood 2 is just to remind you that they're going to come out in pairs. So this x squared is going to come out as an x. This is going to come out as an x. This will come out as an x. Guys, how many x's do I have at the outside? 3. So it'll be x to the power of 3. How many y's come out fully? 3. And I hope this visual helps you with that. Otherwise, it's a little bit weird with fractions and stuff. How many y's stay in? 1. Is this my full, complete, simplified answer? Yep. This is it. Okay? So now, I'm not going to do the visual this time for number 9, but I want you thinking about the importance of why I stressed that number there. Because now my groups are going to come out of this square root in groups of what? 3. So how many A's come out? 2. Go with me, guys? How many B's come out? 1. How many B's are left? 1. And think about cubed root. 8 came out because 24 is 8 times 3, right? And 8 came out as what? 2. So I have 2a squared b times the root of 3b. If you don't like that visual, you would have to look at each of these as like a to the 6th, b to the 4th, and 24 all to the power, let's see if you know what I'm doing, to the power of what? 1/3. And we know the cube root of 24 ends up becoming 2 root 3. And this would become a squared, which is outside. And this would be to the 4/3, which 3 came out as this 1b and 1 stayed in. There's something wrong with my answer, though. No one has brought it to my attention yet.
It's cube root.
Nice job. This is going to be the cubed root there. Good. All right, 2 root 11, that is squared. We're going to apply it to both. And 2 becomes what? 4 root 11 squared becomes 11, so my answer, 44. Guys, the thing is, I don't want to bombard you with easy questions. I'm trying to reduce the number of simple mistakes. Okay? And that's a lot of what we're doing are revolving around simple mistakes. Is this a difference of squares? No, why not? Well, root 3 could be still a square. Not because of that, because it still could be. The thing that I'm trying to say is a difference of squares has to be the same. These are okay. So if it was 4 and 4, it is a difference of squares. If it was 7 and 7, it still is a difference of squares. Those squares don't have to be integer numbers. Okay? Okay. Because think about it. And that was a good mistake. It really is. Misconceptions we're clearing. What I just said is this a difference of squares? Yeah. And a difference of squares has a symmetry about the y-axis. You with me now? So what's the square root of 3? Some people have that memorized, especially from UIL. Most people don't have that memorized, but it's 1.57 stuff, right? It's 1 point stuff, but it's the same on both sides. They don't have to be integers. Okay, so now, I just created a question from that. It was good. We learned from that. Okay. Simplify the expression. We're just going to distribute this out, fold this out. Okay? So what's the first number that I write? 28. The second number? Or, either one. Plus 7 root 3. I'm only doing outside and inside with FOIL. Minus 4 root 3. And then the last number. Not 0. 3. Simple mistakes. It's okay. We're clearing them up. We are multiplying first step. This entire step was multiplication. Okay? So positive times negative will give us a negative. And a square root of 3 squared is 3. All right. What does this become right here? 3 root 3. It's like saying 7x minus 4x. It's 3x. And then combining our constants together, we get what? 25. There's our answer. Okay? Let's come over here. What's that? A lot of people think it's 27.
Oh wait, it's not one.
It's not one term on the inside. We're adding. We have 2 terms on the inside. So this is not this. It's not that. Because there's 2 terms, not 1. And again, because there's 2 terms, not 1, you cannot distribute that on everything. Okay? What's the M word we've been using this week? Multiplicity. So 5 plus root 2, again, because it's addition or subtraction inside, I want you working this out by writing them twice, please. That way you won't forget. Is this a sum of squares? Those don't exist. Good. So this is not a sum of squares. This is just straight up distribution. Please tell me the first number. 25. The outside and the inside numbers, are they the same? Yeah, so there's 2 of them, right? So you could say, straight to it, plus what? 10 root 2. Or if you want to write both of them and then add them by hand, that's fine. 5 root 2 plus 5 root 2. And what's our last term? 2. Our final answer is? Yep, 27 plus 10 root 2. And the only thing that we have to do on the last, on number 13 is what? Rationalize the denominator. So multiply by a form of 1. Now, pay careful to this, close attention to what I'm showing you right now, because we're going to do the same thing in a minute, but it's different. And I want you to tell me why, okay? So 4 over root 3 will multiply with a form of 1. What is it? Root 3 over root 3. And our goal, when we do that, is to get rid of what? The square root in the denominator. Can you have square roots in the numerator?
Yes.
Yes, all day. Okay? So we'll get 4 root 3 And the denominator, anyone? There's 3. And I get this asked a lot. Do these cancel? No. Who can mathematically tell me why? That's in the radical. So that's up here is this. Down here is this. When these are the same, let's say they were both 1/2, then you could do this. You see what I just did? But because they're not the same, you can't bring them together as the same to cancel out. So yes, they would stay just like that, and no, they don't cancel. All right, next one. What do I do? I'm curious to know, some of you remember negative b over 2a and stuff like that. I'm curious to know if you even know the math term of what you're supposed to do here. Don't be shy.
Because you simplify the 6.
No?
Don't multiply by the entire 2 plus root 5. Yeah.
Yeah. So your goal is still to get rid of the what?
The
The radical, the square roots. No square roots in the denominator. But instead of multiplying by the carbon copy of that denominator, please tell me why. It's still a form of 1. But why does this have to be different than that? To cancel out the radicals in the middle as well. You with me? The b term will not exist. So otherwise, what do y'all see right here, guys? Difference of squares. Okay? So this would mean if I distribute it, I'd get 4. Outside is plus 2 root 5. Inside is minus 2 root 5. And that's what I'm saying. That cancels because those were opposite signs. It cancels to 0. And then the last part we would do is multiply that to get a positive times a negative. And then we would just get 5. So the denominator, anyone, is what? Negative 1. Question to you. What do I do with all of this? Just multiply it. And if I multiply it, what do I get?
12 plus 6 root 5.
Yep, 12 plus 6 root 5. What's another way I could have written this answer? Yep, negative 12 minus 6 root 5. Nice. Manipulations. So, in case you don't know, when they create tests, SAT, ACT, all they do is do problems the way you're normally used to. And to make them a little bit more difficult, they do this kind of alteration to the answer so that, you know what I'm saying, your answers look different on A, B, C, and D. So always think that that is their intention, is to manipulate the answer so that, let's say you looked at all the answer choices and they had this as one of them and they had this as the other. And yes, there's like 2 other ones. But what students will do is they'll look at their work and they'll be like, oh, it's closer to that one. I probably just made a negative mistake. I'm going to go with A. But they forget to manipulate. And this is actually your answer. Okay? Those outliers, please don't let them get you. All right, number 15. Please tell me, what do I need to do?
Change the or simplify the radicals.
Let's simplify the radicals. Let's simplify this. What 2 numbers? 5 and 2. Or 25 and 2, which come out as 5 root 2. You still have this 4 root 2. And let's bring this down. What would this simplify to? 3 root 2. Can I add them all right now? Can you tell me mathematically why?
They have to stay the same.
Okay, so you're treating this almost like this, right? Okay, and because of the same term, that's why you can combine the terms. What would you get here as an answer? 6 root 2. In case you didn't see that, guys, mathematically you can do this too. Watch. If I pull out the GCF, right, I'm left with root 2 times 4 plus 5 minus 3. And this is 6. Okay? manipulations. Alright, I believe we're getting close. Yep, 2 more slides and we're done with this lesson. Simplify your expression. So I see a distribution going on, and 3 over x times 8 over 1 would give me, anyone?
Sorry, what was that question?
3 over x times 8 over 1 would give me what? 24 over x. And now if I distribute the 3 over x to the x, what do I get? 3x over x squared. Actually, it would not be 3x over x squared. So, because you're distributing this times x, right? Which is x over 1. So it'd be 3x over x. But my point is, please remember, like we did this week, reduce early. Okay? So, and if you need to on your piece of paper, please do so. Write some little fractions so that you see these cancellations occur so that you're left with 3 over 1. Okay? If this was written as one fraction, just one fraction, one huge fraction, what would that look like?
Like +3 on top and bottom.
No. So this is a good question. It wouldn't be +3 on top and bottom. This is a good question then. Not x squared though, just x. Because look, to combine fractions, you're going to get a common denominator. Notice my multiplication form of 1, so that I could get a common denominator of x. So then it would be 24 plus 3x all over x. Manipulation. Again, guys, this could be one of your answers. And it does, you know what I'm saying? Those outliers that I was trying to describe to you before. Know how to manipulate your answer. This is why I ask you to double check. That's the biggest reason. Alright, let's simplify the next expression. I think you should go to the 2 binomials first and then distribute the -2. Okay, so we have a -2 that will end up distributing on 6x squared. Look at this. -15 plus 2 is -13. And the last, -5. So when I distribute on these 3 terms, I will get -12x squared plus 26x plus 10. Okay? Last one. What do you see? Difference of squares. So difference of squares. The first term is the 7x. The last term is a 9. That's a shortcut if you want to do it. Sometimes some people have seen that, sometimes they haven't. So it simplifies out to what? 49x squared minus 81. That's a difference of squares. Okay? Alright. Last one. Simplify each expression. This kind of goes right here. It was a little bit leading. This is why I asked you that question over here of how you can create one huge fraction. You see what I'm saying? Because you have common denominators. And it was a warm-up to see what you would, if you could know what to do here. Let's simplify this. What could we do? Oh, I see what you're saying. Nice. I wasn't thinking that, but that is definitely something we should think about. You see what he did, guys? Okay.
And it's 1/2.
So then it would become x squared plus 2x minus 3 over 2. And you could say this is simplified for sure.
That's factored.
No, this is an acceptable answer. But now let's manipulate it, right? Let's try to figure out how else could they write this answer. Any suggestions?
That's 1/2. And then in parentheses, x squared plus 2x minus 3.
Okay, you could do that. It's still the same thing though, right? He's saying 1/2 times the numerator, basically. Same thing. So what is this acceptable? acceptable? Yeah, that's correct, right? So we can add fractions because we have the common denominator. Going this way, people see it. People see it. People see it. Especially in our calc class. Going this way, they don't see it as easy, but they need to. Okay? So what we could do is we could break this up into 3 fractions and simplify those to get this. You with me, guys? So each one would get over 2, over 2, over 2. And for this middle one, those 2's would end up canceling to a form of 1, and you would get that. Last one, guys. Last one. Number 20. What's the easiest approach on that, would you suggest? Multiply by 2 over n. Dividing by a fraction is the same as multiplying by its reciprocal. Okay, so this is now over what? 1. What else? Should I distribute or try to cancel? What should I do right now?
Cancel the ends.
You can't cancel the ends. Can someone tell me why you can't cancel the ends? Because it's a whole trinomial and multiplication is right here.
I killed a cat.
You killed a cat?
That's what our teacher said last year. If you did it with addition, you can't cancel the addition.
Because you'll kill a cat?
Yes.
Okay.
Yeah.
Don't kill cats, please. So this subtraction, this addition, you can't cancel in between that. I guess I will use the analogy. Otherwise, we'll kill cats. So don't do that, please. All right. So, oops. Any other suggestions? Can I factor this piece right here? Can I factor that? Let's think about it. The first will multiply to get 9n squared. Could be this. The last 2 numbers will multiply to get 1. And I showed you this before. I have a 3 and I have a 3, which either could give me a 6 or a 0. But I need a what? -1. So it won't work. And if you tried a 9 here and a 1 here, they're more extreme. They're not going to be close to this -1 that I'm needing. Okay? So this you would just distribute. And please do not cancel the ends.
Is it technically, but could you pull out the 2 anyways and not multiply it? Is that considered more simplified?
So that is a good question. Can you pull the 2 out without distributing, and that's more simplified? Here's what I'll say. When you pull the 2 out, it's so that you can cancel with something in the denominator. When you GCF that way, your goal is to cancel it with something in the denominator. If it doesn't cancel, redistribute it back out. That's the simplified version. Great question.